Algebra 1 Quadratic function min and max and word problem. Okay, so we have a little bit more interesting problem to solve using algebra, power of algebra. Using length L string, total length of string is L. Okay, make a rectangle shape and side is X. What is the area of rectangle? That seems to be easy. Find X that makes maximum area. So this is not the linear equation problem, okay, because when side is X, the remaining side is L minus 2X, right? And divide by 2 is another side times X, give you the area. Is that right? So because you have X, and this is gonna be L minus 2X over 2. This side same. Okay, so you expand this L over 2 minus X times X minus X square, right, plus L minus 2X. Okay, so this is a negative, so if you put the graph, it's going to be the max point existing, and the question is asking max area. Okay, max area, how do you find out? Well, you can use that quadratic equation to find out B and C, right? That's a coordinate of this point. Okay, or you can do factoring X, L minus 2 minus X, right? That's a factoring. Okay, and if you set that 0, then X is either 0. That means this going through here, this should be the graph. 1 of root is 0, okay, and X equal L over 2. So this L over 2, 0, the center point is, which is B, right? So it's gonna be L over 4, right? And max is, you plug in L over 4 here. So L over 4, you put this L over 4, L square 16 plus L square 8. Okay, so it's gonna be L square 16. That's the height. Okay, so that's gonna be B, and this is the coordinate of the maximum point here. So when X equals this, the area is going to be this. This is maximum area for the condition x equals L over 4. Okay, you can go over this. So again, you can do that by factoring, or if factoring is not easy, you can always use this formula, B and C. So you can easily get mini and max. Okay, this is a review for the formula. Minimax point and distance to root. This is also the review. The B is center, and this gives you the distance from the root. So if you find the roots, you just add or subtract this distance, you get the center point. Okay, so we went over this in the previous video. And the root could be complex number. Sometimes it doesn't exist. But maximum and minimum still exist here. Okay? So the finding roots and the find minimax is not a really good idea, because sometimes roots doesn't exist. Or you have to use a complex number like this to calculate, and it's not efficient. You can find it, but not efficient. Minimax is directly go by this equation. This equation works all the time. Okay, so I tell you why always works, because imaginary number portion root always become plus or minus, and it's cancelled out to get actual minimum or maximum point. So you can always find minimax in the real number. Even root is imaginary, a complex number. The imaginary number portion, look at this, negative and positive, positive and negative, positive and negative. It's cancelled out. So it's, you use that formula, it's come back to the real number always. So minimax always exists. Okay, so minimax always exists. Whether you use complex number roots or not, the formula is correct to get the minimax. Okay. Now we talk about curve fitting. The curve fitting in the linear equation, you need a 2 point. Then it's straight line we can determine. You have to go back and check the formula when the x1, y1 and x2, y2 are given. We can create mx plus b, right? I hope you remember this. Okay, but for the quadratic equation, 2 point is not enough. You need 3 point, a, b, c. For example, this -1 and -4, 2 and -4, and 3 and 0, 3 point. If you have a 3 point, you enter this. Why you need a 3 point? Because coefficient a, b, c, there are 3 coefficients. In order to uniquely determine a, b, c, you need information on 3 point. Okay, if 2 point, then a, b, c will be indefinite answer. It can be many. Okay, so for example, the graph, if you give 2 point, it could be like that, or it could be like that. There are indefinite number of quadratic equation. If you have a 3-point, then it determines uniquely ABC. We solve this simultaneous linear equation, which we learned in the previous video. Then we can determine ABC. So the curve is uniquely determined. So that's a point here. You need a 3-point to determine quadratic equation. Okay. Now next one is find a function that fit into the following coordinate fit. Okay. This is gonna be the homework for you. Try this out and determine ABC. Okay. Find the function that fit into the following coordinate set. Okay. So we have more practice here, and make a note, get the piece of paper and try this out. Using string L, we make a loop and shape it like a rectangle. We did this. I don't know why the same problem show up twice. A cookie store makes 500 cookies every day and sells each at 80 cents. The cost of making a cookie is 30 cents each. The store makes a daily profit of 50 cents times 500. If this store bakes X cookies more every day, it's need to sell each cookie at the discounted price of 80 minus 0.05x. This kind of marketing formula. 1 cent lower for every 20 cents additional cookie. To sell off all cookies for the day, how many more cookies should store make to maximize the daily profit? How much will the profit increase? So this profit increase, but since the cost is higher, so some point there is a maximum point quantity X give you maximum profit. If you make less profit. If you make more, less profit. Okay? This is going to be your homework too. A cannonball shot at the ground goes up vertically by the height equation, this quadratic formula, and flies horizontally by the horizontal distance equation of this. What is the horizontal distance from point A when the ball hit the ground again? Okay. What you do is 20t2 is x, so t is x over 20, and you put that into y, x over square plus 30 x over 20 plus 10. So this is a trajectory. You have x and y, and trajectory is like this. Okay, so this one you find the roots. One root is 0 because it's shot at 0, and this is distance d. The second root of this equation is going to be distance d. Okay, try this. Well, we're leaving a lot of things as a homework here. Kerry, 6 years older than Tim. When you multiply both age, it's become 55. What is Kerry's age? Okay, so the Kerry's age is x, and when you multiply Kerry's, Tim's age is x. When you multiply both age, it becomes 55. Okay, so this is the x squared plus 6x squared minus 55 equals 0. Okay, so you need to find this, the x by finding factoring. Okay, then you will find out x equal -3 plus -8 and equals 5, because there's no negative h. One of root is physically impossible, so eliminate that answer. So it's a mathematical answer. You have to eliminate that from the final answer. Okay. A square cross was cut into small sides. One side is trimmed by 2 feet and another side was trimmed by 3 feet. The area became the half of the original square. What was the original size? Find the size of one side. Okay. So actually here's the answer. You can save this video and try it by yourself. Draw a line from C to D within a right triangle ABC that is perpendicular to AB. When the length BC is 5, what is the length BD? Here's answer 2. Okay, now next subject we talk about multiple quad equation function. Okay, when you have two quadratic equations and find the x and y that satisfy both equations. Graphically speaking, that's the intersection of two equations. Okay, so what you do is you subtract one equation from another and set the 0. Means this is a common point. So you subtract, it becomes 0. You subtract, it becomes 0. So this is a condition. There are two roots which correspond to this and this, actually this value and this value. Okay, so the problem is the same. It's just finding a root. Finding the roots of single quadratic equation or two quadratic equations. The common point, it's the same problem. Okay, how about one is a quadratic equation, another one is a linear equation. Same thing. You subtract this equals 0. So you will have two crossing point. So it's a root, two roots give you this and give this. Okay, so problem is same. It's reduced to just finding quadratic equations roots. Okay, so what you have to worry about is when you do the same thing, you subtract this from this and set 0. If they don't cross each other, the answer, the root, will be complex number. The roots still exist, but not within real number x, y. You cannot see it because x, y graph shows on the real number domain and the answer is outside of this domain, so you don't see it. So if you use a magic sunglass, you see those two lines are crossing somewhere in the domain of imaginary number. Well, it's a scientific fiction, but you don't see that crossing here because it's an imaginary number. Same thing happened to this. When you have quadratic equation and linear equation, it may not cross at all. Okay, so if you do this, then roots can be complex number. So in this real number domain, you don't see how it's crossed. But again, you have the magical glasses that can see the world of imaginary number, then you see it's crossing. Do you believe or not? It's up to you. Okay? Actually, it's interesting to investigate the relationship between the graphs and imaginary number. Okay? It's not really explored much by the mathematicians, but you could explore it. Okay. I hope you enjoyed it, and thanks for listening.